Hey everybody, this is Larry. This is me going to Q3 of the weekly contest 474, minimum time to complete all deliveries. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. So this one, there are a couple of ways to think about it, and honestly, I totally misread this in the beginning, so I did burn a lot of time there. But even then, it's just what I would say is actually case analysis. I mean, okay, there is a binary search, which if you have enough practice, you'll probably see that part maybe a little bit earlier. If not, well, it's just binary search because then once you have able to find a function that allows you to check whether a target time is fast enough, then we can do more of it in that range, right? But the idea here is or maybe a visualization is more needed. And honestly, during the contest, during the virtual contest, I think that if I had just wasn't stubborn about using my notebook, I probably could have gotten it more quickly. But the idea here is that, okay, let's say you have a number line representing the time, right? You have two colors, you could say. So the recharging thing, I kind of misunderstood in the beginning, but you can think of it as just like a block, right? So here, maybe you can have, every evenly spaced thing, you block it off. And then you have another color that's maybe similar, but, but in a different, and then, maybe they overlap at some points, right? Right? Okay. So the question is really just, can you fit? So now let's say you look at the problem another way, which allows the binary search. Let's say we are given a certain target. Let me change the colors actually, because we're always using red here. You're given a certain target. Can we basically fit all the constraints for this input, right? And the idea is just right. The first is that we're just trying to find out how many spaces there are and how to fill them out, right? And that's really the core part. And for that, it is just a combination of what I was going to say, case analysis and also inclusion exclusion. It's a very simple version of inclusion exclusion because there are only two things, but and the first thing is, for example, right, you have just overlaps. What does overlaps mean? Overlaps means just that like nothing can use it, right? So we just kind of remove them out, right? And how do you know how many of them are there? Let's say this is 3 and this is 2. Then okay, I mean the math doesn't really work out. I guess in this case this is actually 3 and 4, right? At least the way that I drew it. So this is 3 and this is 4, right? Spaces, right? Or recharge on every, or maybe this is 5 and 4 because there are 4 spaces within it. Whatever, it's not that actually important, right? Then now that means that they match on every 12, right? Because that's just, because if you just write out 3, 6, 9, 12, you have 4, 8, 12, ... right? So I mean, I'm not going to go over how least common multiple works for this because I feel like if you're attempting realistically and honestly to yourself a Q3, you should know how least this is how you figure out how many times they overlap, right? By getting the least common multiple, and and because we know that this happens every 12 times, say, which is the LCM. That looks like LLM, which is me telling you to cheat or something. But no, LCM is equal to 12. Then let's say we have a target of say 1,000. Then it just comes in every 12 times, so it's just 1,000 over 12. So that means that this amount of space, let's just call it L over LCM, is the number of space that no one can use, right? No one, right? Okay. And then now, I thought the next part is just about in a greedy way. Okay, we already removed all the overlaps, right? Then now we want to say, so instead of trying to figure out, okay, we have a space which person to use, maybe it gets filled out or whatever. So like, for example, if you saturate this one, then or like, maybe there's some weird configuration where you ran out of numbers on the on the top row, and then you just couldn't figure out if you're greedy in the wrong way. So it is greedy, but you have to greedy in the right way. And the way that to allocate this is just, well, there's all these uses where there's one block and then the other's open, right? Well, in the open one, then in a greedy way, this can only fit this robot or whatever, right? So yeah, so then here we fit it, or we do the math, we fit it all in, and we also fit it all into the other one. And then now whatever's left over, right, can be used by both. And that's really the core part about this, is just doing all that together. And that's given a certain n. And then if a certain n is possible, then you just make it smaller, right? That's the basis of binary search. And if a certain n is not possible, then you make it bigger, because then it fits in more cells, right? Or more deliveries. Okay. And this is kind of the core code that I have. This is the binary search. I'm not going to go over it that much in this video. It is just honestly a pretty straightforward binary search. And just to be frank, binary search is probably like a Q2 difficulty thing. So you have to like know it very well in general. And it comes up in interviews and stuff like that. It is a good code to learn it very well. So not in the context of this video per se, but yeah. I think this part's the more interesting part. And I got the variable names are kind of terrible. If you watch the new, if you watched me solve it live, you'll see how I get here, but it's not great, right? So basically, yeah, these names are actually terrible. I don't know, but I kind of So overlap. This is the stuff that. Overlap is you go to things no one can use, and as we said, we just do the LCM of the two recharging frequencies, and then we do it by target, right? Okay. Otherwise, we have target, right? Is that the best way? Okay, so let's actually go over delta first, right? So okay, so overlap, things no one can use. I think there's no disagreement there. Delta 1 is actually delta. I mean, 1 and 2 is the same, which is that what we said, which is kind of the recharging period of the second robot that we can greedily use for the first robot, right? So basically, target divided by R sub 1 is just the recharging period of the other thing, right? Of the other robot, because we know that they're recharging, we can use this without thinking about it, right? But of course, this overcounts the number of them, because we have to remove the ones that are overlap, right? Because if they're overlap, then you can, the first robot cannot use it either. Right, so it's just this minus this, and then yeah, and maybe I should have done it the other way, actually, the signs. But in either case, and then this is the number of deliveries that they have to do. So that means that if delta 1 is positive, then we've done all the deliveries that need to do. If this is negative, that means that this part is bigger than this part, right? That means that we have deliveries left over. Same for delta 2. Hopefully you get the symmetry and I don't have to explain it again. If not, then just watch it again with me saying, but in your mind replace 2 with 1 or something like that. I don't know. So then after that, it is just about getting the number of days that, or hours or whatever, number of slots in which both can use. And that's what available is. Available is the number of slots both robots can use. And of course, yeah, this is also inclusion exclusion, right? We subtracted from one of the robots, subtracted from the other robot, and then we add back in the overlap. And so then now this just counts number of slots that both robots can use. And this is actually maybe I should make it more clear, but this is Googleable. It's called the inclusion-exclusion principle. So, sorry, I'm trying to think, but I don't. People sometimes call this PIE, PIE for principle of inclusion-exclusion. I think I'm right? Is that I mean, I know it, but maybe my naming is wrong. But I think that's the name of it. Inclusion-exclusion principle. I don't know. Either way. So yeah, there's a good wealth of literature on this part. So definitely just hopefully that makes sense. And this applies to the number of things very well. And so yeah. So as I said, if delta 1 is negative, then we have to use it from the availability thing from the both slots. So then we just do that. And if delta 2 is negative, we still have days left for the second robot as well. So we kind of do that. Remember that this is negative, so that's why the plus thing. And at the end, if we still have, or if we use them all and it's 0, if we still have slots open, then we can try a smaller number. And that's basically what this binary search allows us to do. And that's it. What's the complexity here, right? Well, this loop is going to do O of B, where B is the number of bits, right? Or bits in the bound, if you say, which is going to be like, I don't know, 10 to the 9, I suppose. I mean, you probably could do a tighter bound, honestly. But I did 10 to 20 because I didn't want to think about it. It's only 30 loops. And this isn't even like I mean, I was going to say it's not a linear thing, but I guess it is because they're two things. But I don't know. It's constant this is effectively constant because there are only two things. So I wasn't worried about like this being too big or anything. That's basically why. But you can probably do a tighter bound, and that tighter bound might include I think 10 to the 9 times like 2 or something like that should be enough to the pigeonhole or something. Maybe even get even a more tighter bound than that. Maybe like 10 to the 9 plus, I don't know, 3 times 10 to the 4th times like 2 or something. I don't know. Something. You can definitely make it tighter, but it's not necessary for me to even think about. So I just kind of made it really big. And the way that I choose it, if you are curious, is that I see 10 to the 9. I double it in case there's a 10 to the 9 times 10 to the 9 thing that I didn't see. And then I make it a little bit bigger than that by a factor or a couple of factors so that I don't have to think about it. Sometimes I am wrong on this, by the way. So that's why I'm talking about it. But yeah, so the number of bits, and each of this is say O of 1, right? So that's it. It's going to be blazing fast, I suppose. Oh, Leetcode contest things, sometimes they don't show up. I don't know. But yeah, but that's it. That's all I have for this one. Yeah, let me know what you think. Let me make it small so it fits in one screen. Okay, maybe it's too small now, though. But yeah, let me know what you think. Thanks for watching. And you can watch me try to solve this problem during the contest next. Miss a case, okay. Okay, two integer of 2 arrays. My screen wasn't bright enough, so I was confused. Wait, D1, D2. Make Zhong I must make. Okay, so Zhong has to do 3 deliveries. What's R? Must recharge every R hours. Okay. Oh, this is so weird. I wish they give it like 2 drunks instead of in a way of 2 elements. That's just like a really weird way of representing data from a data structure kind of view. But okay, so 5, right? Is it just brute force? I don't get it. Oh wait, no. It recharges. I don't get it actually. Wait, let me double check. Only. Okay, I see. So then it. Is it just brute force? No, because it's 10 to the 9. I guess that's the thing. There's some weird pigeonhole thing there. So you have to. So you can't simulate. I guess that's the thing. It feels binary searchy, but maybe not even. How do I think about this? The thing is that they don't. I mean, even if they overlap, it's okay because it's even if they overlap, it's not going to be like unless they overlap in the last number. It shouldn't matter, right? Because then you just. I think there's a case analysis, but I think if you, yeah. Or if D is equal to 1, I suppose. Oh, no, not D, R. Wait, R is always 2. So that means that there are always going to be gaps. That's what I was thinking about. So if there are always gaps, then it almost doesn't really matter. Is that true? Yeah, because even if they overlap, then then in the future they'll be in sync anyway, except for if it's the last particular thing, right? Okay. So then we can like simplify a lot of it. ATAR, PTPR. I think that's more intuitive to me. Okay, so then now start with A. So then it's going to end at so it starts at 1. Oh wait, what is this? Did I misunderstood this? What is D? How did this deliver at... What is R again? R is recharging time, right? Maybe I misunderstood this actually. Every R hours. I thought they make one delivery and then they recharge. Maybe I misunderstood this actually. I think this is the opposite of what I was thinking, because I was thinking something else. Okay, so they recharge. So that means those are the only times they cannot make a delivery, and then you fit in everything else. So maybe it is binary search then, because then you could do the math that way on whether you could fit it or not, right? Okay, yeah, I think that's true. Maybe I'm not, though, but okay. Okay, yeah. Let's just do something like this. So your left is 0. I totally misread this one, though. I don't know. Let's just make it big. I don't want to think about it. I totally misread this, though. Okay. So it's good you want to see something smaller. Otherwise, you do something bigger. And we just return left. Right? And then now this is target, right? Okay, so then now, how many of them are recharges? Right? So basically that's just, okay, 3 is equal to target, or available maybe. And then, we subtract by the number of hours. So it charges at 2. So if it's 6, it's 6 divided by 2. Okay, so R sub 0 or target divided by this. Right. Maybe this could be a for loop, and then we have to do the exclusion thing, right? Is it LCM? I was going to just multiply them, but that's not quite right? It should be the LCM. Yeah. Okay, fine. Okay. And then now we have to Is that it? That's just okay. How many slots we can do, and it doesn't really matter, right? So just return available is. Oh, that's not true. Because you have to take account D of how many deliveries. No, does that matter? Like, can we just do this? No, because you don't have. Why can't you just do this? Charges at 3. Choose. So this means that this is force more than it is, right? Mm, 11 we have. Okay, 10 is still good. We have 10 is good. 3. Oh no, 10 is no good. Why is 10 no good? 10 is no good because we think there's only 3 days available. Because we subtract 5 days, we subtract 3 days. That's 8. We add in 6. So that's. What did I say? Subtract 8 days, and so there's 3 days left. Is there not 3 days left? Oh wait, because this is not quite right. Because it could, one of them could be used by the other. Okay, so I'm definitely not right on the formulation, but some of it is right. This means that we don't use either. That's for sure, right? Then how do we formulate the other part? So we definitely don't use the sex, but one of them has to be used by the other, right? So we do kind of like okay, so we want to start by saying okay, then we just kind of greedily okay, so D0 we use the R1's charges, right? So while R1 is charging, so if this is the case, maybe that's fine. Well, yeah. I mean, it's something like this, but it's not quite right, right? Because then now it is this. This is R1 charging minus this, right? Okay, let's say overlap is equal to this. Then now we minus the overlap. So if something like that, would that be right? Let's see. Well, apparently it's infinity because this keeps on returning false, maybe? Why? Just double checking that wasn't like a syntax thing. Or maybe it is. You never know. I meant not syntax, but like a order of operation thing. Did I miss someone? Oh, I did. Okay. So it's force all the way. Why? Target. Oh, the overlap. This should be true, right? This. Oh no, this is target. So it's this minus the. So they overlap completely, but that cannot be true. It's 6, right? So overlap is target. How can this be the same? Why is overlap the same? Did I mess something up? LCM of R0. Man, maybe I'm just doing something really funky. It's 2? Why is it 2? Oh, it's looking at example 2 now. That's why. Okay, so maybe that's why. Let's take a look at the first one real quick, to at least to see if it's giving me the right answer. It's hard to say because it's not putting the answer. Thank you, Leetcode. Okay, I'll put 15. I mean, it's wrong, but at least we're validating what we want to do correctly. Okay. True. 15. At some point, it is force. Why? We want to look at, say, 6 or... Well, okay. So for 14... Oh, because we don't always only over... So, okay. I missed some other available days. That's why. Because this is... Okay, so we prioritize this. Because that's the... Okay, so then now... Okay, fine. So delta 1 is equal to this thing, right? Maybe? And then delta 2 is equal to this thing, maybe. I don't know. Right? So we need to find these 2 days. Okay, so then now the number of 3 available days is just I mean something like this, but I'm like blanking out a little bit. Okay, maybe this is where I do need paper though. Okay, so there's a lot of inclusion, exclusion. Okay, so I don't even know if the delta one is quite right. Okay, so this is all the numbers of, so we prioritize fitting it there and fitting it in the other one. But then now for delta 1, if it is negative, that means we want to use days that are so then that's where we had this thing. So what is available now is, it is the days that that have no overlaps, I think, right? Or these are the days that have no association with either day. So then now we return available is plus delta 1 plus delta 2 is greater than 0, maybe? No, that's not quite right. But okay, so if delta 1 is less than 0, then we right? something like this maybe. All right. I mean, that matched the thing. How did I get like reset test cases? And one big money. Okay, I don't know what that means. 573 looks okay. Let's just try one big case just for. I mean, because why not, right? We're here. Whatever, it doesn't matter. They're relatively prime. I guess I don't know the answer, but at least we know that it's not taking a long time. So YOLO submit. Hopefully, please. Okay. That was kind of a tricky one to set up. Oh, did I open the queue? Okay, yeah, I was like, we just did. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.